Hello, how are you doing?
Yeah, good. How are you?
Doing fantastic, thank you. A pleasure to virtually meet you. Uh, Looks like we have a standard algorithmic interview for today. To help me target the interview appropriately for you, it would be helpful as much as you're willing to give me the information to know kind of what your experience level is. Right now I have what I have anonymously. It just tells me you have like 0 years of experience. You're a college student level, which is fine. If you got any more insight to that or experience that you want to reveal, that's great. And then if you could, any general companies or levels you're targeting there, it would be great.
Okay. So you can call me Jason. I'm now a new graduate student, and I have no work experience before, and I'm going to have an interview for TikTok next week, so I'm prepared for it.
Okay, great. Not so sure about TikTok because I haven't been there, but did you say you are working, you have no experience, so this is kind of your entry level position?
Yeah.
Okay, wonderful. I can definitely try and help you out there. Appreciate you sharing that bit of insight. And let me go ahead and share just a little bit of some standard guidance that I give to everybody that I give interviews. And this is, I actually give this in real life interviews as well, just so people know what to expect. There's a couple of goals for this interview process. A lot of times you're like, hey, I'm never going to use this algorithm actually in the real world. And that's probably true in most cases. But there's a couple of goals for the questions that we ask. And when I say we, this is me in this practice interview. And when you get your actual interview, you'll get some other random theoretical thing that you'll never actually use in real life. But there's two goals for that. One is just to show that you can write code. You'd be surprised how many people get to a coding interview and don't actually know how to write basic code. So demonstrating a little bit of proficiency in the language that you claim to have proficiency in is always great. And then a second goal is to learn how you think and how you solve problems. So typically the questions you get are kind of going to have kind of an easy half of them, where you just, you write the basic part or it's not even efficient code, but then you need to start thinking creatively and using your knowledge of the language and certain constructs to do other ways to solve the problem than maybe the one you solved the first time. So those are kind of the two main goals. Don't worry too much, especially in this practice interview. Don't worry about typos or style, indentation, all that kind of stuff. It's the algorithm or how you think that's the main focus of this interview. Do please think aloud. The worst thing you can do is just type and struggle and not say anything. And I can only watch and see what you do without actually learning how you're thinking, or maybe you had an idea and you rejected it. That's actually good information for an interviewer to know. Is if you think that something's a bad idea, just go ahead and say that, and that communicates to them that this is an inefficient approach or this doesn't work because whatever. So anything you can communicate as you think through it is helpful to your process. Don't worry about mistakes. 90% of the time in these interviews, people make mistakes. It's usually fine. Sometimes they find it themselves later. Sometimes I point it out. As long as you quickly say, oh yeah, that was stupid, I mean this, it's totally fine. So sound good? Ready to go?
Yeah, that's good.
All right, fantastic. In the upper right corner of your screen, you see something that says plain text as a drop down. If you click that, you can choose it to the language of your choice, which you just did, which appears to be Java, so that's great. And then the previous comments are here at the bottom, and I will be posting, actually I'll go ahead and post it up at the top of of this class here, so that you'll have a place to refer to it. Okay, so your lucky question today Sorry, I'm copying and pasting something here. All right. All right, so I am giving you a two-dimensional array, and you can see the example there starting on line 9. And it is an array of integers, ones and zeros representing land and water. If you see a value of 0, it's water. If you see a value of 1, it is land. With me so far? Okay. An island is connections of contiguous ones that just form a group of land. So you can see, for example, on the top row, starting in the upper right corner, there's a 1 to the right, and then 2 ones below it. And I've actually put some examples down there on line 21. You can kind of see that that represented the first island. You can see in the lower right-hand corner, there's a second island. It's got a 1 in the top right, and it goes to the right 1, and then down 1. So that's the middle column there starting on line 21. You can see that as an example. And then finally, there are 2 islands there's a third island. It's on row 10, the 5th column over. You've got a 1, you go right by 1, and then down by 1. So that's the third column shown on line 21 as a third shape. And there is a 4th island on line 12 of the code, 3rd column over. And you can see it's the same, it looks the same as the one in the top left corner. You start, you go to the right one, and you go down 2 ones. So it's the same shape of island. Okay. So there's 4 total islands, but there's only 3 uniquely shaped islands. So your goal is to write an algorithm that will tell me that there are 3 island shapes in that matrix.
Okay. Yeah, I think I understand the question. So I'm thinking of like doing it by this week, and I want to like look from the top left to go through the whole 2D array, and once I like meet one space called is filled with 1, I will like use a helper function and to go through all the adjacent space, and if there are also 1, I will like keep I will recurse it, like okay. I will redo this work, and once I like done with 1, I will like modify it to 0 and like keep checking all the adjacent ones and like keep doing it until I cannot find a 1 of it, all the adjacent, or I touch the boundary.
Okay.
And I will loop using this method to loop this whole map and count the number of islands. You think it's good?
Okay, that sounds like a good approach to start with. Obviously, you'll hit some more details when you get implementing it, but go ahead and get started and see where you get.
Okay, cool. So can I assume that I will get the input this one to the array? Like
yes. You can assume I'm giving you that array as input. You can probably even copy and paste it into your code if you wanted to actually run it.
Okay. I will have a integer called count to store the number of items, and I will like first I will get the length and width of the map. So do we know like the lower boundary of the learn width? Can they be 0 or something?
Good question. Let's assume that it's always going to be non-zero.
Okay.
And then, and since you sort of assumed it, I'll just tell you, you can assume that it's going to be rectangular, that all of the rows are going to be the same.
Okay.
Checking the length of the first one will work for all of them. That's fine. That's a reasonable assumption.
Okay. They are like, okay, they are at the same length. Good. So just like use one integer to like get it, and I will do the loop. And if we have like an island in this space, it will be equals to 1. So here I will like enter helper function, and I will input the map, also input our count to it.
All right.
Okay. And then at last for this function, I will just return the count. And then we will have to write our function. So take two input, one is the count of island, one is our map. And no, we don't need to input the count, I think. We only need to like plus count here once we have a 1.
Okay.
Yeah, and I will like we will like look for the boundaries. We will like first, before we enter our helper function, we need to modify the space to 0.
Okay.
And we then look at, we then go through the, actually we can do this in the helper function. Yeah. Delete this count, do this in the helper function, and then we go through the first check if we meet the boundaries. Let me check this one. Since this will be the above our current cell.
Okay.
So wait a second. Yeah, we need to like input our coordinate. I didn't notice this before, so we will have like an I and a J. We'll have to think I and J for the rows and columns. And it could be in J. And we'll do the similar for other 3 JSON. adjacent cells.
Okay.
I can just like copy paste this one. It's like not elegant. Plus one smaller than B. J minus one. J minus one. This will be J plus one. Yeah, and in this way, I think we will get the result, and we can like have few test cases to try if it is good. So, and do this one here. Just like our 2D map right here, and we just use the example case.
Okay.
Okay. Can I initially like this? I think I can do this. Okay, I'll put the result. I will try to run it to see if there is some bugs here. You think it's good? Okay, there. Maybe I can't initial not like this. Okay, it's because this one.
I think with Java, you may need to use a different syntax for that array.
Yeah, maybe like I will try to do it.
Try it with curly braces. I think that
Oh, I
might work.
think I need to use a different. I think I need to use this one. Wait a second. This one. Hold on. Maybe I need to.
There you go.
Yeah, modify all the things.
Be nice if all the different languages use the same syntax for these.
Yeah. Okay. Looks good. Okay. Yeah, I think we have the result 4 here.
Okay, so good. You found all the islands, but now you need to figure out which ones are different.
Okay. Okay, that would be a different question, I think. To figure out the different.
The question, remember I said we wanted the unique islands, so you're looking for the shapes. So you've effectively counted that there are 4 islands, but you need to show that there's 2 that look the same, so you really want the number 3 as your result.
Okay. Yeah, question. Something. Shape.
So what are you thinking right now?
I'm thinking that right now I'm thinking like I can like get all the top left cell of each island.
Okay.
Into like into a list. And then I try to wait a sec. Unique shapes.
So when I use the word unique or distinct, does that prompt any thoughts in your mind?
I was thinking of like using hash set or something like this.
Okay, great. That's great intuition. So you need to find something that you can stick into a set that represents an island.
Yeah, but the question now is like how to like put the shape to a set.
Right. Okay. So that's fine. That's the problem you need to solve now. So how do you represent a shape in a way that you can put into a set? So you know how sets work generally? How do they eliminate duplicates? What's kind of the standard type of set you might use in Java?
Standard type for what? For shape?
Well, standard set implementation. Set's an interface, but you usually instantiate a particular type of the set.
Yeah, I think I want to use hash set.
Okay, great. So you need to know, you need a set, or you need an object that you can hash, that you can have a unique hash associated with it.
Yeah.
So what kinds of objects in Java do you know that are easily hashable?
Like integer or string.
Okay.
For this one, I think it's integer.
Yeah, well, an integer is already just going to be some value that's going to be kind of unique, and then but you can hash a string, so that's great. So let's think about let's talk about, see if you can create a string out of this island shape somehow. So
Yeah.
how are you determining the island shape?
Like how many rows they have and how many like items in one row, and they have to be in the same position.
Okay, that's great. Well, let's just look at your actual code, which I think you have basically your helper method starting on line 55. That's how you're navigating the island recursively, right?
Yeah, 55. Yeah.
Yeah. So, by the way, what kind of, I know you just called it helper method. Is there a standard kind of algorithmic name for what you're doing there? A particular search?
Like it's a BFS, I think.
Okay. So a depth first search, right?
Okay. Yes.
Okay. Now let's take a look at this method. If I were to give you the same island, you know, like say you start in the upper left and you navigate that island, and then there was the one in the third column, I think third or fourth row down. Yeah, third column, fourth row, that's the same shape. Would you navigate that island in the same order?
Yeah, I think for this two, I will navigate in the same order, but
Okay,
not
yeah.
all the islands.
So you're always going to check the I-1 first, and then the I+1 second, and then the J-1, and then the J+1. So for any given set of islands, those orders are predictable. So all you need to do is kind of keep track of which direction you move when you're going through recursion and throw that into a string somehow.
Okay. Move in the thing.
So let's take a look at line 58. You're checking I-1. What direction does that represent?
Up. It's checking up.
So you could maybe add the character U for up or N for north or whatever you wanted to a string.
Okay.
And then the same thing for the other.
Okay, I get it. I would like, sure. So we'll need, okay. So I would like, when I move, I will like, for here, I will add one more input, a string S, and whenever this is, like movable, before I going in, I will like let this S to have, like, U, one called U, means I move up.
Okay. That's
And,
great. That's great intuition. Let me ask you a quick question. Are strings mutable in Java?
mutable?
If you pass string as a parameter, S, and then I do S plus equals, does that actually do anything?
I think they are mutable.
Okay. So they actually are strings. You cannot change a string once you create it.
Okay. I cannot change the string.
Right. So there are other structures that you can add characters to.
Yeah, I mean, I can use a string builder.
Okay, string builder is a great idea. So maybe you pass a string builder.
Okay. So it will be called a string builder, and I will like and so yeah. And for the other four, I would like put it into the input. for the other two, I always have one left. So, this is down, and this is left, this is right. Okay, so now we'll have a string for each item, and I will have to create a hash set of string. And once we have made up one, I will like build a string builder. Into it, and this one. It's a string.
Okay.
And let's see. Oh. Yeah, see? Yeah. Yeah. And then I will just return the, I'll have no need for the count. I will just like return the size for our hash set.
Okay.
Yeah, I think this may be a word.
All right. You're getting close.
So
if you run this, you're going to get the number 2, but you can see if I'm right.
okay, I'll try it. Yeah, I'll get 3.
It works. You got the correct answer there. So I may have been wrong with my guess. But let me see. Yeah. Okay.
You want to try some other test cases?
Well, I think it happened to be the order that you did the up, down, left, right that made a difference. So yeah, that actually worked. If you had done left, right, up, down in a different order. So do me a favor here. Go down in your line 60 through 71. So those first 2 checks for up and down. And copy and paste them after your left and right checks.
Okay.
Basically, yeah. So logically, that should still work with your code, right?
Yeah.
All right. So now run it and see what happens. Aha, it still works for you. Okay. All right. Here's the problem that we have. And it actually might be good. There are some certain shapes where if you take a look on line 21 and you see the right, so you see the 2 shapes in the right-hand side. One, you go to the right and then you go down, and the second one you also go to the right and then you go down.
Yeah. Okay, I get it. Yeah.
But those will both show up as RD as your strings, and so I'm a little bit confused why they're not.
Okay, so I think I can like in my helper function, I can add a not to the condition y faces 0. That would solve this question.
All right, so basically, yeah, add one more character. So yeah, there's a certain sequence of left, right, up, down, which would have given you the answer too, is the bottom line.
Yeah, I think, yeah. Okay. Right. Oh, I get it. If I put the going right first, I will have a 2, I think. I want to check it out. Oh,
Yeah.
okay. I don't know.
The reproducible failing test case here is if you go right and then down in that order, which it looks like it should. I don't know why it's working for you. Actually, that's kind of funny.
Yeah, I also think. It doesn't. Yeah, I get it. It shouldn't work, but it worked.
Yeah, there's something weird. But anyway, there's some reason it's slightly different, and it may be just how you initialize things or something. Because yeah, those should both show up as right down. All right. Well, anyway. I bet if you output the set, if you print line the set, it'll give us some insight.
Okay.
Here I am debugging why your code is working. That should not be that way. What recognizes the problem?
Try to see.
You should just be able to on line 54, just do a print line of the result.toString.
Yes. I'm just gonna print result. Yeah. It's RD3.
Oh, okay. So there's a problem. There's a definite problem here. You're going down one and you're never going right. So there is a bug.
Wow. See.
It's the one where you go down first and then right. Okay. I'm wondering if your I's and J's might be switched. No, you're going down first. A plus 1. Oh, I see it.
Okay. Well,
You're doing map.length. You only have 6 rows in map, but you have 7 columns. So your check condition on rows 61 and 67 should be.
I think. Yeah, I thought that was like. Oh, sorry. No, nothing. Yeah. this is W and so here moving.
You made your W the same as your L there on line 44.
Yeah. Okay. Yeah, I think now it'll be have the bug we think. Yeah, now it's 2.
Okay, there you go. There you go.
Okay, so we can focus by
You made your W the same as your L though, and on line 44.
W L 944. Okay. Oh, sorry. Yeah.
I swear you did that earlier, but yeah, now it's right. Okay.
Yeah. Okay. So I need to like put some more characters in it when it's not what I think. So here. Yes, that's 0. So if it's not, we'll like append some more. And then like
Okay.
R.
Let me stop you right here and tell you this is not going to work because it's going to behave differently at the boundaries than it is otherwise.
I don't think it will happen when it's with the boundaries. It's if when we check it's 1 or else.
Your 2 RDD shapes, the one on the top is not going to be able to go to the left, so it'll fail that.
Get it.
It'll fail the I-1 or the J-1 condition.
Yeah, I get it. So let me see.
Just append something at the very beginning before you do any of those.
Oh, cool. I get it. When I do every loop, I can like, yeah, you're right. I can just append like this is the like loop 1 kind of thing. Maybe no.
Honestly, I think any character there will work.
This is weird. Yeah. You don't think this gonna work?
Well, I think it'll, as you're doing it, it'll work, but I think you're over-engineering it. I think you could just put a space there or any character other than L, R, U, or D. And I think it'll work.
Cool. Oh, good. Okay. I think I can just like add a character here.
Yep.
Okay. Let's try. Oh. Okay. I don't think this works. It still give us 2.
So how come you're not? Okay, so maybe I was wrong here. I'm trying to think.
I can just like.
Go ahead. Well, do it your way.
I'm thinking like add the index, like the row number and column number into it. And I think it will solve the question.
Yeah, actually, I think maybe rather than doing it at the beginning, if you did it at the end and said, hey, I've looked all the 4 different directions. No, because you're always going to end up at the end.
Yeah, we always do. Let me just like.
No, that's fun.
Oh, no. That would be not good. This is not good. Okay.
What was the loop way you were doing before?
Yeah. Mm-hmm.
Because on one of them, you would be doing it on the first level, on another one, you'd be doing it on the second level.
So, okay. Mm. I think I'll just. I think I just use the loops.
There you go. I think that'll probably work.
Yeah. Yeah, this works. Yeah, this will cause a new input.
All right, excellent. I think you got it though.
Cool. This is a very interesting question.
Okay, great. So let me just ask you a couple of questions about this, the standard ones. What do you think is the computational complexity of this code?
I think the time complexity would be the time complexity for loop would be O n squared, and the yeah, I think that's the large time complexity, and the space is also O n squared.
Okay, so when you say n squared, you've got a matrix with rows and columns. So which one?
Yeah. I mean the n plus n. Yeah.
Oh, so order of n times n is what you're saying?
Yeah.
So how about the searches themselves? Is that included in your calculation, or how would you factor for that?
The what? Sorry.
Well, your helper function.
Yeah, I think I mean.
So we know you're going through the entire array once to look at every square once. Then the question is, are you
No.
more often than that or not?
Yeah, I think no. I think include the helper function. It'll be like n squared times n squared.
Okay.
And Yeah, and the space complexity will be, I think, be uh, would be unintentional. The string we put in the hashtag will not exceed the strength of our map, so it will be unintentional.
Okay. All right, sounds good. I think we have about 9 minutes left, and there's usually about 5 minutes for feedback, so we don't really have time to jump into a new question, but I think we've kind of beat this one to death. So let's just go ahead and end here. I'm going to offer you, if you want, I can give you some real-time feedback, or I also want to just give you, I'll be giving you written feedback afterwards. So if you prefer to just ask other questions right now, you can feel free. I'll just give you the rest of the interview time to ask any questions you have. Or if you'd like some verbal feedback right now, I can give you that as well.
I would like some feedback right now.
Okay, wonderful. Yeah, and I'll follow this up written anyway, but I can give you a feedback. Overall, you did really well. I will tell you, I'm going to mark down your communications, and the reason for that is not necessarily verbal communications. It's a lot of it is just like the variable name and that kind of stuff. And everyone likes to use I's and J's, and that's great if you're just counting things. But when you're actually representing something physical, like a map of an ocean, it would be good to use directional things, like north, south, east, or west, or rows and columns, or things other than I and J. So even right now, after solving this with you, looking at your code, if you ask me, is I the row or is I the column, and is J the row, is J the column, I would not be able to tell you that off the top of my head. Do you know that off the top of your head?
I know, but I know it's confusing.
So there you go. Obviously, single variable letter names are fine. Like L and W for length and width were great. But when you get to I and J, and then it starts to get a little bit more confusing. So just something to think about. Verbose variable names are always good. Verbose method names are good. Like you have a count island method, that's great. And then you have this helper method. Well, yes, I know it's a helper, but I prompted you and asked what sort of a method is, and it took a little bit of questioning to see it was a depth first search method, right?
Yeah.
So naming it DFS would have been a little bit better. And again, this sounds like nitpicky, but in an interview environment, you want your interviewer to understand exactly what you're doing, and actually in a real world coding environment, you want to write code that is very clear. And I often see very long multi-word variable names in production code because you kind of want it to be self-documenting and what's on there. So that's kind of one of those key feedback points I want to give you. It'll help in an interview if the interviewer understands what you're doing. And as well as in production environment. I did have to prompt a little bit about, how are you going to remove duplicates? And we talked about string immutability and stuff like that. So that's kind of a gotcha, especially for Java. Definitely know what you were able to quickly say, hey, let's use a string builder, and that's great. That's knowing string builder exists is a big plus. So that shows a little bit about the language, but do have an idea of when you pass a variable in a argument that you're not going to be able to modify it. Like the way you did loop is fine because you're not expecting loop to be returned. But when you initially wrote your code, you eventually deleted it so it didn't stick there. But initially, I think you were passing count around as a variable or something like that, and that would not have worked. Fortunately, you deleted it, but just an idea of what happens when you pass a argument to a method, knowing which objects are mutable. Primitives and strings are not mutable, so when you pass them to a function, you're not going to be able to change them. So So that's where you go. A big plus for you, and it may have swung you from the almost failing to, hey, you're going to pass, is when I pointed out that there was a problem in your code. Even when you got the right answer, you did not give up. You're like, okay, I'm going to figure out what's wrong with my code and fix it. And that impressed me. So great job doing that. You know, you didn't say, well, it's right, I'm getting the right answer. You realized that right answer for the wrong reason is not appropriate, and you dug in until the two of us found the problem together. So great job there. And I even suggested, I guess, probably a wrong solution to the problem, and you got a better correct solution by passing that loop variable, which is what you're going to do to begin with before I said you were overcomplicating it. So I do think there's an easier solution, but I'm not sure that under the time constraints of this interview that we would find it. So great job there. So yeah, you did a great job. A little bit of prompting required, but you know that's just nervousness or trying to think under pressure. But with a little bit of prompting and you didn't give up and you went after things. The only thing I would suggest is just be a little bit more clear on variable naming or use comments or do other things just to make it easier for the interviewer to follow along where you're going.
Okay. Cool.
All right. That's it. Any other questions you have for me?
How would you rate the question? Is it a medium question or easy question?
It actually is on LeetCode somewhere. I think it's called Count Unique Islands. I think you have to be a member to have access to it, but it counts as a LeetCode medium. It's a LeetCode medium level question, and those are the level you're going to get on your interviews. Easy is really too easy. As a software engineer, you're not going to get easy, and then hard is going to be too hard for you to answer in the space of an interview, so they're not going to give you that one either. So you're going to get LeetCode medium level questions on your interview. Have you ever heard of the site neetcode.io?
Yeah, I heard it.
Yeah, that is a great site. Obviously knowing how to do all the LeetCode is great, but there's no way you can do all the hundreds of those things. That site really boils it down to, I think there's like a blind 75, and then there's an additional, there's a whole LeetCode 150 or something. Those are great because they cover all the different types of things. Again, don't just work to solve the problem, but understand the solution, understand why you got that solution, what are the different ways to solve that problem and why didn't you do it? I used to ask, if you remember two-sum, it's a LeetCode easy problem, but there's like 3 different ways to solve it. And I used to ask that one and I would tell people, okay, solve it all 3 ways. And that kind of turned it from easy into hard because you kind of had to think of all the different ways to do that. But just approaching it that way, thinking it in terms of it's not the solution that matters, it's how you got there and what are the data structures you use, and showing that you know about hash sets and hash maps and the fact that they're order 0 lookups, and that's great. And all of those, just those types of things are what people are looking for. And throwing that out there during an interview is great. It's like, well, this would be really more efficient because I'm using a hash set and that's an order 1 lookup. Just throw that knowledge out there in your interview, and you show your command of the language and your knowledge of algorithms and stuff like that. So you definitely want to communicate that to the interviewer. All right.
Okay. Cool. Am I supposed to show 2 questions today, not just 1?
Well, this was sort of 2 questions. It was a count islands and then a count unique islands. Sometimes you get to 2 questions if you solve one super fast. In our case, we did some debugging work and we explored some great things during that debugging, and that kind of counted as your second question. If you had solved this super fast, I would have given you a more challenging second question. And I have a stumper that always stumps everybody. So don't worry about that happening. If you interviewers like to push you until your breaking point. So if you solve something great and then they give you a really hard one and then you fail, it may not be a failure. It's a testing your limits and seeing what you do when you don't know how to solve something. So that's a good thing when it happens in an interview.
So if that happens, I should just talk about what I'm thinking 就是说。
Yeah. Always talk about your thinking, your problem-solving approach. Just any intuition you have. Like if you hear the word unique, you should immediately say, "Oh, this means a hash map or a hash set." That's kind of your knee-jerk reaction should be something like that. And when that comes up in an interview, you'll think that. If you have a matching problem or palindromes or anything like that, you should say, "Oh, this is a stack-based solution. So I'm going to be using a stack in here somewhere. I don't know where yet, but something like that." And that's kind of where the LeetCode problems will help you out. They'll say, "Oh, this is the right time to use a depth first search. This is the right time to use a stack," and those kind of unique data structures. And one more data structure, if you haven't learned it yet, is a try. Make sure you know how to use that. There's a boggle problem. If you haven't solved that, solve boggle. That's a very helpful problem.
Yes, try map me.
What's that?
Is a try this one?
Try, yeah. It's conceptually it's nested hash maps. So you can have a map where you look up a map inside that. It's used for file paths or REST paths or a lot of path-based things where you can get a really fast lookup. That in combination with a breadth first search or a depth first search, it gives you a really great caching mechanism to look things up faster the second time around. So the canonical example is the classic boggle question, where you, here I'm just going to copy and paste at the very bottom of our screen. I'm posting the standard question. They give you a boggle board where you try and create words, and you're going to have a dictionary. And if you're just doing a single version of that, you can just do a depth first search and find the answer. But what makes it interesting is if they say, "I'm going to give you a very large number of words, a whole dictionary of words that I want you to check," then you want to store your partial solutions along the way, and that's where you want to use a try.
Okay, yeah.
Okay?
Okay.
All right. Great job. Great talking to you, and best of luck with your interview.
Yeah, thank you. Thank you very much.
Yeah, okay.